Hello everyone, Mike from Morton Lights here. Today I want to go through my build of my Hanson Electronics DMX2-24 board. Let's just quickly get into it. I gave a quick overview of this in my behind the scenes video for 2023 and just touched on how it works, but I've had some questions again about how it all pieces together, so here we go showing you. So this here is the actual board that Hanson sells. As you can see on the very left, there's the two grey 8P8C sockets, which is your DMX in and loop. The green headers across the top and the bottom allow you to connect the two wire light strings to it, and they basically work by reversing the polarity to get the A or the B lit up. On the end of that, you've got a DC 20 to 40 volt input that you match to your lights. Most of the ones sold here in Australia are 31 volts, so I run very similar to that. A fuse, which is for the entire board, and then a set of dip switches there which set the DMX address from 1 through to 511, the start address, and it uses 24 channels. And then the first dip switch there allows you to switch 12 channel mode, where I like calling the A and the B of a channel pair are doing exactly the same thing. The little blue header, switch header at the top, allows you to select between a couple of test modes and classic effects and what have you with the button switching it, so that kind of matches to the way the typical old multifunction controllers worked. And then there's an in-circuit programmer header on the side for reprogramming the PIC chip, which did need to be done this year. There was a bug that Alan managed to fix, and I did a bit of testing on him for that, so that fixed that one up. Here's the main box from the outside. Across the bottom there, you've got 3 4-way solar glands that have the 12 pigtails, and each pair of channels is delivered on a single pigtail. The blue cable, which is a Cat5 cable terminating to an 8P8C, is for DMX out, and the 2 white cables on the right-hand side are the 24 volt in and out connections. That all is designed to connect into my 24 volt backbone. Now, if we take a peek inside the unit, you can see at the bottom there is the DMX unit. The pigtails are all ferruled and connected in. The Cat5 cable coming out the bottom, plugging into the right-hand jack, the left-hand jack going up and around to the boards at the top, and then the two 24 volt leads coming into those two BP connectors at the top. The red board in the top right is a boost converter, so that's taking the 24 volts in and stepping it up to around 32 volts or so. I run it a little bit higher than the 31 because I do have one 36 volt prop that I use, and there's no damage to the others. And then the yellow board on the left-hand side there has got 3 subboards on it. There is the ESP32 with the metal can on it. The blue board on the left is an RS422 converter, and a little board hanging off the top is a buck converter that is converting the 24 volts down to 5 volts. This here shows my 24 volt input. I use the Anderson power pole connectors. They're great because I can just connect anything to anywhere. Polarity is always maintained, and I really don't care about ins and outs in this particular case because I just run single chains, but it means that I can just put any prop anywhere I like. This is a close-up of the boost converter, very, very basic design, 2 MOSFETs, a coil, a couple of capacitors, and that is basically taking in the 24 volts on the red-black on the right and putting out the 32 volts on the red-white on the left, and there's a little pot at the bottom there for adjusting the output voltage. This is a close-up of the control board. So we have here, you can see that little blue and white pair that goes on. That's the 24 volts from the main connection coming into that buck converter there. That buck converter connects to both the 2 other boards there. The ESP32 is basically a standalone unit. You can see the antenna cable coming off the top, and that also connects into the other RS422 board. And then the orange-white twisted pair coming out goes to the 8P8C that's plugged in. So that's the DMX line there. This is the bottom of the board, very simple point-to-point wiring. Essentially, the white is the ground, connects to a couple of the ground pins on the ESP32 and onto the module. The green is the 5-volt line, so that is connecting to the ESP32's pin, the power pin on the RS422, and also to the data, the send and receive data header, which basically decides is this module sending or receiving. That forces it always into send only mode. And then the antenna that I've got is just this little one, and I've just hot glued it to the inside of the lid, and that gave me pretty good reception in my yard. Close up of the pigtails, so nothing special about those. Standard 2-wire ferrite pigtails with the 8P8C DMX output coming out there. And I've labelled all the pigtails with their channel numbers, as you can see in this picture here. This is a high-level diagram of how it's all connected up. So the red voltage, black ground, blue is the data. So you can see GPIO2, which is that fifth pin from the bottom on the right-hand side of the ESP32, goes to the data in of the RS422 converter, and then the AB outputs go into pins 1 and 2, the orange pair in the 8P8C. The brown pair in the 8P8C is grounded. Now there is a slight error in this diagram. I've got a ground connection going to the DERE pins. That should actually be a 5-volt connection. And basically that says the transmit enable is on and the receive enable is off. The receive enable is a logical not of the input. Buck converter in the bottom right and bottom center is the boost converter pushing up to the 32 volts, and the power poles at the bottom for my input. From a configuration perspective, now this has got ESPixelstick 4 loaded on it. This is the home screen here of it operating, so you can see that it's connected to my SSID. I've configured it for 512 channels on single universe, and it hooks into the Wi-Fi. Wi-Fi setup, standard, SSID password and DHCP, and it's just got a host name of Pixelstick DMX, nothing special there. All the fun stuff here comes on the device setup tab. So you give it a name, blanking time, primary input I'm using E131, and output 1, which is that pin 2, the GPIO2, is a DMX output. And then I've said for E131, it's universe number 1, 512 channels, and starting at channel 1. So that is just going to basically take in the one universe and dump it directly out physically as one universe of DMX. And then the dip switches on the DMX2-24 are set to channel 1. And at the bottom, you can see I've set the entire 512 channels to be outputted as well. I found that if I put that down to the 24 that the DMX2-24 used, it would just increase the flickering a bit more as it was feeding it in at a much higher frame rate because it was taking a lot less time to send those frames. X-Lights, the configuration was quite straightforward. Set it as an ESPixelstick, version 4 with an ESP32 variant. Standard setting of laying out the models. The IP address I use host names on my network, E131, and 512 channels per universe. And then in the visualizer, I just drag each of my channels onto the serial port 1, which is the DMX output. And then that would just work as expected. I don't push that configuration into the ESPixelstick. There's no reason to, because it's transmitting the entire universe out to that device, and it's looking for it and sending it off. So that's it, quite a straightforward little setup. The pin 2 of the pixel stick coming through to the RS422, which converts it into the DMX data that's being read. And then it's got the other advantage in that, because I've got that extra 8P8C and Cat5 coming out the end, that I can reuse that for any other DMX props in the future should I need it. Single universe of E131 over Wi-Fi worked well. I didn't have any lag or issues like that because it was just a small amount of data. I do not use Wi-Fi anywhere else in the show, just for this year. And maybe one day I'll upgrade it to an ESP32 with Ethernet, but for the moment, this is what I've got. So thanks everyone for watching. If there's any questions, pop them in the comments below. Reach out to me on Oz Christmas Lighting as Skymaster, or visit my website, www.mortonlights.com. Thanks everyone. Bye.